Hello, good day viewers. In this tutorial, we're going to see the Norton's theorems. So Norton's theorem, the difference between the Nortons and Thevenins, it is not much more, the difference between them. So therefore, in Thevenin's theorem, we're talking about the Thevenin voltage, and we talk about the Thevenin resistance. But in Norton's theorem, we talk about the Norton's current, and therefore we talk about the Norton's resistor. It is just an interchanging between them. This we are dealing with Thevenin, and this we are dealing with Norton's, and we are doing in Thevenin, we are dealing with Norton's. So therefore, basic idea that I want you to know in this Norton's theorem is that, as I said, there is a circuit. I have a current. This is the Norton's current, and therefore this is Norton's resistance, and therefore this is RL, and therefore we are asked again to find the current through this RL. So therefore the Norton's resistance is the same thing as finding the Thevenin resistance. So therefore we have to find the equivalent resistance here, and we have to short circuit the voltage, and therefore we have to open circuit the value of currents. So this should now be equals to, we have the resistance here, and therefore also we have resistance, and we have an open circuit here, and therefore we have an open circuit. And therefore we have to short circuit this. Okay, open circuit, we short circuit the value of the voltage, and therefore we have resistance. We have 3 amps of current, and therefore we have also 3 amps of current, and we have the 8 amps of current. So the next thing that we're going to do is that we all know that this and this are they're in series or parallel. This and this are in series. So therefore this should now be 11, and therefore 11 it is parallel to Let's check whether it is parallel or. Let's redraw the circuit. Let's say we have this. After making it in series, it should now be should now be this. The circuit should now be this. And this is an open circuit. There will be no current through this. So therefore we have we have 11 amps, and we have 3 ohms. So we have to find because the resistance are in parallel. So we have to say it now be equals to R1 plus 1 over 1 over R2, or rather we can say it should now be equals to 1 over R1 plus 1 over 1 over R2, all to the power of -1. So let me check my calculator and see. So therefore if I say the value of R, this should now be 1 over 1 over 11 plus 1 over 3 all to the power of -1. So this should now be 2.35. So therefore the value the equivalence, the RN should now be, the Norton's current should now be 2.35 amps. So therefore the next thing to do is that I have to find the Norton's current. So how can I find the Norton's current? To find the Norton's current, the first thing is that I have to open circuit the RL as usual. Let me say I have it like this. I have something like this. I have the RL, and therefore I have the 6 ohm. So I have to short circuit it. Okay, sorry, open circuit. I have to open circuit this. Open circuit. So therefore I open circuit this. If I open circuit this, the next thing to do is that we have to find the Norton's current. So we cannot find the Norton's current directly, but we have to first find we have to first find the VC. We all know that this is the same thing as E. Let's forget it about and say this is B, and let's name it as as point C. And we all know that this is the same thing as at this 100. So therefore the current it is passing through this junction, and therefore this current is going through this junction, and therefore the current cannot go here because of because we have an open circuit. So therefore the current shall go directly to the 3 ohm resistance. So the next thing that I'm going to do is that I have to use a nodal analysis. Nodal analysis, before I have to take this as I1, this as my I2, and this as my my I3. So therefore the current going, which is positive I1, plus the current going the junction, this is a node. So therefore it should now be what? I2, and therefore minus what? The current is leaving the what? It is leaving the node because it is going down. It is going to the what? To the I3. Okay, sorry, to the resistance what? 30 ohm. So therefore should now be negative I3. This should now be equals to 0. So as we all know that I is the same thing as V over what? R according to Ohm's law. So the next thing that I'm going to do is that I have to say that value of I should now be 100 minus what? VC. 100 minus what? Minus VC divided by the resistance, which is what? Which is 8 ohms, and therefore what? Plus I2, we have the value of I2 directly, so therefore no need of putting V1 or 100 minus something, no need of saying either VA minus what? BC. Even in nodal analysis, you can check the description of the video, you can see how to find the nodal analysis, so that you can what? So that you can know it more. So therefore I already have the value of what? Of this current, so this shall now be what? 7, and therefore minus what? I3 is from VC to what? To VV. So therefore the VV is the same thing as what? 0, because it is the source of the ground. So therefore, but I have to say this VC minus what? Minus 0 divided by the value of what? 3 ohm resistance. But this resistance, they are in series, because the current should now go here off to what? Off to 30. It starts from here. So therefore I have 3 plus 30, which is 6, and all should now be equals to 0. So the next thing that I'm going to do is that I have to multiply both sides by the LCM of this as what? 24. 8 multiplied by 6. Let me verify it. 8 multiplied by 6, we all know it's 24. Okay, sorry, 8 multiplied by what? 8 multiplied by 6, it is what? It is 48. But if we use 48, we'll get again the right answer. But since 24, since 8 can go into 24, if we say 24 divided by 8, it will give us 3. So therefore, if I say 24 divided by the value of 6, again, it will go at 4. So therefore, 48 and 24, they are the LCM. But let me take 84. You can also take what? 48, and it will give you the same what? The same equation that you're going to form. So the next thing is that if I multiply this by what? By 24, multiply this by what? 24, because I'm going to multiply both sides by 24, and therefore this, it will give me 0. So therefore 24 by 8, as I say, it will give me what? 3. 24 by 8, it will give me 3. So therefore I have 3 into 100 minus what? Minus VC. Minus BC plus what? If I say 24 multiplied by what? By 7, I should now get 168. So therefore I have to say minus 24 into, it will give me 4, shall now be 4 multiplied by VC, it will now be 4 VC. Yes, this is 1, shall now be equals to 0. What I did here is that I said 24 into 100 minus what? Minus VC divided by the value of 8. So therefore this shall now go, it will give me what? I end with what? 3 into what? 100 minus VC. This is how I get this. So the next thing is that how I get this thing. I said 24 multiplied by 7, it give me what? 168. So the next thing is that how I get this minus 4 BC. I have 24 into what? VC minus 0 divided by the value of what? 6. If 6 can go here, I'll get what? 4, and this I'll get 1. So this will now be equals to what? 4 into what? VC minus 0. So therefore if I distribute this bracket, I should now get what? 4 VC minus what? 0. 4 times it will give me, so this is the same thing as 4 BC. And don't forget I have my negative sign since here. So let me proceed. So the next thing that I'm going to do is that I'll distribute this bracket. This shall now become what? Shall now become 300, and therefore minus what? Minus 3 BC plus what? Plus 168 minus what? 4 BC shall not be equals to 0. This multiplied by this 300, this multiplied by this negative 3 BC, I should now carve this down. So therefore I have to collect like terms. If I collect like times 300 plus this, I should now get what? 468. This and this, it will give me what? Minus what? 4 plus 7, 4 plus 8 will give me 7 VC, should now be equals to 0. So therefore 468, I should now say 468, this will now be 468. When the negative 7VC cross the equal sign, it shall now be equal to 7VC. So as I said, this will now, if I divide both sides by 7, because I'm looking for the VC, this should now be cancelled this, and therefore the 468 divided by the value of what? 7 should now be equal to VC. So now what shall now be the value of VC? If I say 468 divided by the value of 7, this shall now be equals to what? 66 point what? 0.85. Yes. So let me clean it. So as you can see, I'm looking for the value of what? In. So I have to take a look and see, this is what? This is VC. I already find is 66 point what? 0.85. The voltage node is not, but I'm looking for In. So now what shall I do? And I say that in the last video I talked about VC is the same thing as what? VA, and therefore why VA is the same as what? Thevenin. So VA now is, we have the value of this, and VA is now the what? Thevenin. So for now, let me just take a look to this. I have this. If I check this, and see, this is a what? This is a voltage divider. Yeah, this is a voltage divider. So if I'm going to use the voltage divider, as I say, this is R2, this is R, and therefore I'm looking for what? The Thevenin. This is what? The what? The VT, the Thevenin, what? The Thevenin voltage. So the next thing that I'm going to do is that this will be the Thevenin voltage should now be equals to what? VC multiplied by what? Multiplied by R3 divided by what? R2 plus R3. So therefore the Thevenin should now be equals to what? The value of VC, which is 66.85, and therefore into what? The value of 3 divided by what? 6. This plus this, it will give me 6. So therefore this is the same thing as half. So therefore 66.85 multiplied by what? Half. So half of 66, it will give me what? This will give me what? 33.4 to what? 425. But let me check. If I say 66.85 divided by the value of 2, yeah, it will give me point. Yes, that's correct. So therefore for now I will say the Thevenin voltage should now be equal to 33.452. Wow, this is very interesting. Up till now I'm looking for the value of the current of the what? The Norton's current. So I find the value of VC, then I find the value of, because you cannot rather find what? Because we are using the Thevenin voltage in order to find what? In order to find what? In order to find the what? The Norton's current. We are using this to find this. But if says of we are doing with what? The extent that we are dealing with Thevenin's theorem, whenever as long as we find this, so this VC should now be equivalent as what? As our Thevenin voltage. But don't forget, this is not voltage, it is currents. So that's the reason that we cannot directly substitute it. So therefore this should now be, the Norton's current should now be equals to what? The Thevenin divided by what? Divided by the Rn, which was the Norton's current. So therefore the Thevenin should now be what? 33.452 divided by the value of what? The current, yes, which is 2.35. So what should I go in to get the value of what? The Norton's current. So the Norton's current should now be, if I say 33.425 divided by 2.3 what? 2.35. So this should now be equals to what? 14.22 what? Amps of current. So therefore, okay, I don't have to delete this. So the next thing is that I have to say the Norton's current should now be equals to what? 14.22 amps of current. So then I'm looking for what? All this thing that I'm doing, I'm looking for this what? IL, the current that is passing through what? Through the load resistance. So I have to draw this circuit. So I have to say I have the currents going up, and I have what? I have this, and I have this, and also I have what? Yes, the RL. And I'm looking for what? I'm looking for IL. This is what? Rn, and the value of Rn is the same thing as 2 point what? Which is 2.35 amps, and therefore the the Norton's current is now becomes to 14.22. So how can I find this RL? And my RL, it is what? It is 6 amps. So now, to find the RL, I have to use the current divider. The current divider, it says that I'm looking for what IL. So therefore, this is current. So I have to multiply by what? The current IN, the Norton's current. And therefore, I have to say, I'm looking through this what? Through this Rn. So therefore, I have to say Rn divided by what? The summation of what? Of this resistance. So therefore, I have to say what? Rn plus what? Plus RL. So the next that I'm going to do is that it should now be equal to the Norton's current, which should now be what? 14.22, all multiplied by what? The Norton's resistance should now be 2.35 divided by the summation of this, and it should now be equals to what? 2.35 plus what? Plus 6. What should I going to get? So let me check. This will now be equals to 14.22 multiplied by what? Multiplied by 2.35 divided by the value of 2.35. 2.35. Okay. Sorry. I made a mistake. I have to say plus 6. So this should now be equals to 4 amps current. So therefore, the IL should now be equals to what? Should now be equals to 4 amps current. So this is all I have for you in Norton's theorem. I hope this video is more helpful to you on how to, many things. You know how to determine the Thevenin resistance in Norton's, and you know how to determine the Rn, the Vc, and and the In. Don't forget to subscribe to this YouTube channel. Thanks you for watching, and have a nice day.